Howdy! Today I'm going to show you how to make this Tic Tac Toe game using HTML and CSS with a smidge of SVG. We're going to use Pug and Stylus as preprocessors, but you'll be able to grab all the compiled HTML CSS code from the demos. We're going to use a form for our game, so we create a form element with the class name game. A Tic Tac Toe board consists of 9 cells, and each of those cells provides the opportunity to either place a naught or a cross. So what we can do is use a for loop to generate 18 checkboxes. For each iteration, we create 2 checkboxes. Input type is checkbox, and then we can use template literals to generate an ID. Here we're going to do x hyphen and then the index in the loop. And we can do the same for naughts with o hyphen and the index of the loop. And this will generate 18 checkboxes. And we can see here the generated IDs through 0 to 8. Next we need an element for the board, so we're going to create a div with the class name board. This is where we're going to generate the cells for the board, so we can use the same for loop as before. For let I equals 0, I is less than 9, I++. For each iteration we're going to create a div with the class board cell, and inside this element we're going to create 2 labels that control the checkboxes. We can use the for attribute with a template literal to match up to the IDs we defined for the checkboxes. So here we have for x hyphen I, which would match up to input type checkbox with an ID of x hyphen I. Let's give our label some text using the template literal, and let's go with cross, and we'll print out the index. And we can do the same for naught, where we change the text to naught, and we match up the ID with the o hyphen I goes to input type checkbox with an ID of o hyphen I. If we look at our page, we now have 18 checkboxes and 18 labels, and clicking certain labels will toggle the state for certain checkboxes. So we've generated a form there with 18 checkboxes and 18 labels, and we're using Pug with template literals to generate these IDs that match between them. And doing so means that we have labels that we can click to toggle checkboxes, leaning on that native HTML behavior. And this is going to come in handy when we implement how we change the turns during the game. We have the foundation for our game board here, and we can click labels to toggle the state of the checkboxes. However, when we get to the end of the game, there'll be no way to reset without doing a refresh. And this is why we use a form element. So if we use a button with the type of reset, and we're going to give it the text reset board, this will give us a way to actually reset the form without having to refresh the page. Now we can press any label and hit reset board, and our checkbox state will return to its initial value. So hit cross 1, naught 2, cross 3, reset board, and the checkbox is returned to their initial value. So here we're hooking up a button with type reset within the form, and this will just allow us to reset the game state at the end of each game, and means the users won't have to refresh the page in order to restart a game. Now we want to lay out the board for our Tic Tac Toe game in a 3x3 grid. We're going to start by defining a CSS variable for the size of our grid, and we're going to go with 50 vmin. Now we're going to apply that size to our board with height var size and width var size. And now we're going to lay this out in a grid using display grid. And for our grid, we want 3 columns, so we can use grid template columns, 1fr, 1fr, 1fr. And that gives us 3 equal width columns because we're using 3 fractions. Alternatively, we could write this as repeat 3, 1fr. If we look in DevTools, we can now see that our board has a 3x3 grid. And that's because we defined 3 columns and we have a height and width. And because we have 9 elements, implicitly, we get 3 rows. But we could also explicitly set the rows with grid template rows, repeat 3, 1fr. Lastly, to align things, let's use place items, center. And now we can see the cells in our grid have all been centered within their grid position. At this stage, we have the board, and we've given it an explicit size, and we're using display grid to create that 3x3 grid required for Tic Tac Toe. To define the number of columns and rows, we're using grid template columns and grid template rows, and to align the items, we're using place items, and we've gone with center. This is arguably the trickiest part of the Tic Tac Toe game to implement. What we want to do is show and hide the labels for the noughts and crosses based on the turn. So if we click cross, then we should only show the naught labels, and then if we click a naught, we should only be showing the cross labels. To do this, we can use a combination of the check pseudo selector with the general sibling combinator. Here we're saying when an input is checked, find the next sibling with the class name board, and then within that, find a board cell, and then a label of env of type odd, and then let's give it a color of red. Now if we look at our demo and we click the label for 0, 0, now all of our cross labels turn red, and that's because when this input was checked, it looked for a general sibling with the class name board, and then a child with the class name board cell, and then a label which was env of type odd, which in this case is every label that is a cross. At the same time, we'll want to style the other labels so that they don't appear. So we can use the same selector, but instead of using label env of type odd, we can use env of type even, and we can set these for now to color green. But this is only going to work for the first turn, and therefore we're going to have to write extra rules to cater for each turn. So for turn 2, we actually use the pseudo selector checked, then find the next general sibling that is checked, and then find the board and then the board cell. But this time we want the label that is env of type even. And now we can see that all the labels are red when we have 2 checkboxes selected. And now we want to make all the cross labels green. So we can repeat the rule, but this time it's going to be find a pseudo selector checked, a general sibling that is checked, and then for every board cell where the label is env of type odd, make that label green. And now we can see that the cross labels are green and the naught labels are red. If we reset the board and go through those moves, if we hit 0, 0, now all the noughts are green and the crosses are red. And then if we hit cross 1, all the crosses go green and all the noughts go red. To implement the logic for the rest of the turns, we keep chaining the check selector and then flipping the type of the label within the board cell. Once we've typed out all the combinations, we end up with something like this. And what we're going to do is we're going to show these labels and we're going to hide these ones. To make this easier to interpret, let's set a color on the labels. Let's say for every odd label, the color is red, and for every even label, the color is green. We can then match the state of our board to one of the rules we've created. So for our example, we have 3 checked checkboxes, and the labels that are shown are of color red. So we know that we are looking for a label that is env of type odd that follows 3 elements who are in the checked state. So this rule is the one that's currently active. Checked, 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 followed by an element whose class name is board, the child board cell, and then the label env of type odd. At this stage, we've implemented the mechanism for our Tic Tac Toe game, and without it, this wouldn't work. We're leveraging the fact that we can click labels to toggle checkboxes, and then we're using the general sibling combinator to show and hide the different turns, and this is what makes it possible. The mechanism for our Tic Tac Toe board works well, but the issue is we're not blocking our users from reusing the same cell. So for example, we can hit 0, 0, but then we can hit cross 0, which wouldn't be possible. What we need is some elements to cover a cell once that cell has been selected. To do this, we can create some elements that we're going to overlay on the board and absolutely position based on the cell index. We're going to set a custom CSS variable x with the value x, and a custom variable y with the value y. We'll also create an adjacent element for the naught checkbox, and that will have a similar style but a different class name. What do we want for the value of x and y? Well, x will be I modulo 3, and y will be math.floor I over 3. If we look in DevTools, we can see that the inline CSS variables have been generated for our overlay elements. We can see that the first overlay element with the class x has an x of 0 and a y of 0. The second x overlay has an x of 1, a y of 0. The third has an x of 2 and a y of 0, and so on, covering all of the coordinates of our grid. Next, we need to style our overlay elements. They're going to be position absolute, and we need a size for each cell. So we're going to set cell size is calc var size divided by 3. And then we can set the height and the width to that cell size. Let's give our overlays some color so we can see them. So for our noughts, we'll go background, HSLA, 50%, 50%, 0.4. And for our crosses, we'll do the same, but we'll go background, HSLA, 210, 50, 50, 0.4. And we can see that all of our overlays are in this top left corner of the board. To set the positioning, we can use CSS calc, and we can use var x times var cell size for the left positioning, and for the top positioning we can use calc var y times var cell size. Our overlay elements aren't positioned relatively to the game board. To fix that, we can set position relative on the game class. The issue we have now is that our checkboxes and our reset button are affecting the size of the game board. To solve this, we can position them outside of the board. If we inspect the DOM with DevTools, we can see that our overlay elements are now positioned correctly and taking up the right amount of space for each cell. So at this stage, we've used Pug to generate some overlay elements that we've then absolutely positioned based on some inline CSS variables that we've generated with JavaScript. We're using those CSS variables to then absolutely position the overlays on top of the grid. And that will block users being able to use the same cell more than once, which is kind of ideal for Tic Tac Toe. At this stage, our Tic Tac Toe board is almost working. I've gone ahead and styled the board cells using the nested feature of Stylus to size them to the right cell size and with relative positioning. The labels are now also absolutely positioned and assume the height and width of the cell. But there's an issue. The overlays aren't blocking use of each cell. To fix this, we can set a z-index of 2 on our overlays, and now we can't click the labels. We only want to display the overlay for a cell that has been clicked, so let's start by setting a default of display none. Then to display an overlay for a cell, we can use the adjacent sibling combinator. Here we're saying select a div that is the adjacent sibling to an element that is in the checked state. And then we're going to set display block. To make this easier to visualize, we're going to set a faint background on the board of HSLA 0010 0.1. And then we're going to remove the text for our labels and set some text for our overlays. So we have naught and cross. Now when we click a cell, we should see the correct overlay being shown, and we can't re-click a cell to change its state. We can keep going until we fill up the board, and the only way to reset the board state is to hit this reset button or refresh the page. To review, we're using the adjacent sibling combinator to select an overlay element for a cell when an input for a cell has been checked. By showing the overlay, we then block that cell being reused. Our Tic Tac Toe board now works, but we aren't detecting or displaying a result. Let's start by adding elements for the different results. Here we're creating a div with the class GameResult, and we're going to give it a second class of GameResult --x, and its content will be x wins. We can do the same for the noughts win and a draw. By default, we want to hide all game results, so we can set display none on game result. To show the correct result of CSS, we can use the general sibling combinator again, in combination with the IDs of our inputs. For example, we know that if x0 was checked, x1 was checked, and x2 was checked, x would have a line, and therefore crosses would win. And then we could show the game result for x wins. To do this, we can use the ID selector in combination with the checked pseudo selector, and then we can use the general sibling selector. Once we have a winning combination, then we use the general sibling selector to select the correct game result. And we need to do this for all possible combinations. Once we have all possible combinations, we set display block. If we check our demo, we can see that it's telling us that noughts have won, and that's correct, because 00 is checked, 04 is checked, and 08 is checked. But it would also be true because 02 is checked, 04 is checked, and 06 is checked. If we reset the board, we can also check that this works for crosses by doing a combination that works. So here, x1 is checked, x4 is checked, and x7 is checked. But how do we detect a draw? To detect a draw, we know that we would have 9 checkboxes, all checked. And then we can select game result, draw, and set that to display block. And we can see in our demo that it's telling us that our current board results in a draw. However, what if we won on the final move? Well then, we would show 2 game results, draw and a win, which isn't what we want. To fix this, we can use another nested selector and use game result draw under a winning combination and set display none. And we can see that that has hidden the draw result. This logic gives us the ability to determine the result of our Tic Tac Toe game. By checking for different ID combinations, we can tell the result, and by counting the amount of checkboxes, we can tell if there's a draw or not. We now have all of the functionality, and from here on out, we can start making things look a bit cooler. Our Tic Tac Toe board needs lines, and to create them, we can use SVG. We need 4 lines, so we can use a for loop. So let's do for let equals 0, L is less than 4, L plus plus. And for each iteration, we're going to create an SVG with the class board line. We're going to set a view box for our SVG, and let's go with 0, 0, 10, 300. And then we're going to use a path element, and then we're going to set a D attribute which defines the path to be drawn. We're going to move to the 0.55, and then we're going to draw a line to 0.5295. Then we're going to define a stroke width of 10, a stroke line cap of round, and a stroke of black. That creates a huge SVG, so let's apply some styles so we can see what we have. Let's also give our line a temporary background of red, and if we look closely, we can see the bounds of our line element with these red corners. For our line, we're using a path, and we're defining for our path that we move to 0.55, and then we draw a line down to 5295. The reason we don't go from 0, 0 to 0, 300 is because we're using a stroke width of 10 and a line cap of round, and we want to see the line cap. If we update the line's move to 50, we can see that we lose the line cap. But if we apply overflow visible, we can see the line cap coming out of the bounds. To review, we can use SVG to draw all kinds of shapes. Our Tic Tac Toe board needs lines, so we're using the path element to draw some lines. And we can use the D attribute to define those paths. Here we're saying move to 0.55 and then draw a line to 5295. The reason we don't go from 0 to 300 is because we have a stroke width of 10 and we want a round line cap. And we need to accommodate for this. So we move to 55 instead of 0, 0 in order to see that line cap. Our lines aren't positioned correctly, and we want to position 2 going vertically and 2 going horizontally. To start, let's make all of our lines start from the same position. We can do this with top 50 and left 50. And then if we set a transform of translate minus 50%, all of the lines are centered on the board. 2 of our lines will need to be rotated 90 degrees, and then all of our lines will either be shifted a little bit to the left or a little bit to the right. To do this, we can use Scoped CSS Variables. And let's start with a rotate of calc var rotate with a fallback value of 0 and then times minus 90 degrees. We won't see a change here until we inline a variable. Let's create a variable of rotate for each line, and this will be equal to L modulo 2. And then we can set that value inline on the style property. Style rotate and rotate like so. When we reload our page, now 2 of our lines are rotated by 90 degrees. To calculate the shift, we can use modulo and a ternary. We'll say if 2 modulo L plus 1, then 1, else negative 1. And then we'll pass that value as an inline CSS variable too. And then we need to update our transform for that shift. We can use translate x with a value of calc var shift times var size over 3 times 0.5. And that puts all of our lines into the correct position. In that final translate, we're saying shift the line on the x-axis by the value of the size over 3, which would be 1 cell, and then half of that. And we multiply it by the shift we calculated in the markup. For example, the first line is not rotated and shifts -1, so it goes across to the left. But our fourth line is rotated and shifts upwards because we've rotated and then we've shifted. So it would rotate and then shift up. To review, we're using Scoped CSS Variables with chain CSS transforms to lay out the lines for our Tic Tac Toe board. This is quite a nifty technique because we only need to define the one transform property, and then we let the CSS variables in combination with calc work out the positions for the different lines. So in our example, we translate all of the lines by -50% and -50%. That puts them all at a common start point in the center. Then we rotate them optionally based on a CSS variable. And then lastly, we translate them either left or right based on a CSS variable. But if that line's rotated, left or right will actually look like up or down. We need noughts and crosses. Let's create a naught. Let's start by converting this div with class O to an SVG, and let's add a viewbox attribute with the value 0, 0, 100, 100, and we can remove the text content. Then within that SVG, we're going to create a circle element. It's going to have a radius of 30 using the R attribute, a center point on the x-axis of 50, and a center point on the y-axis of 50. Let's give it the same stroke width as our lines below, and also the same line cap of round. We'll give it a black stroke and no fill. If we check our demo, now we have a naught, and this has been defined by our circle element, where the R attribute gives us a radius, so a radius of 30, based on a viewbox of 0, 0, 100, 100. So our SVG would go from 0 to 100, 0 to 100, the radius is 30, the center X is 50, and the center Y would be 50, which gives it that central positioning. This is a way for us to create circles with SVG, and it will be handy for when we want to animate these circles as if they're being drawn on. We can use the circle element within an SVG to create circle elements, and specific attributes on the circle element will define sizing and positioning of the circle relative to the SVG's viewbox. Our Tic Tac Toe board has naught, but now it needs crosses. To do this, we can convert our X element overlay to an SVG, and we can set a viewbox of 0, 0, 100, 100. And let's remove the text content. We could use a single path to draw a cross, but in our case, we want to animate the cross as if it's being drawn by hand. So we're going to use two paths. For our first path, we move to position 80, 20, and then we draw a line to 20, 80. And we can give that a stroke of black, and if we check in the browser, that gives us this diagonal line. For our second path, we're going to start by moving to 20, 20, and then we're going to draw a line to 80, 80. And this will also have a stroke of black. If we check the demo, we now have a cross, and we can proceed to give it a matching stroke width and line cap. And that gives us a cross. Now we've created a cross, and we use multiple paths inside an SVG to do that. The reason for this is that when we come to animating our cross, we want it to seem like it's hand drawn. So we'd do one path, then the other path. Instead of if we had put them together as one, they'd animate at the same time, which wouldn't look quite right. We have our functioning tic-tac-toe grid, but it doesn't look very appealing. So let's define some color that we can use. Let's start with a background color, and let's go with HSL 210, 50%, and 15%. And then we can apply that directly to the body. And then we can define some colors for our SVG elements. Here we've defined a color for noughts, a color for crosses, and a color for the lines. And we're going to use CSS variable scoping to apply those. We're going to use SVG stroke var stroke. Then on the relevant elements, we can set that stroke variable to the color we want. So for board line, we can set stroke to var line. We won't see an update yet though, because we still have inline stroke on those elements. So let's remove those strokes. And now we can see our color is being used for the stroke of the lines. And if we update naught and cross to use their stroke, their colors will also be used, as we can see. If we remove our stroke declaration, we'll no longer see the element. And that's because we didn't provide a fallback value. So if we go back to our SVG declaration and provide a fallback value of black, now we can see our crosses again. But personally, the purple looks a little bit nicer. Here we've looked at how you can use custom CSS variables and scope to style things. Here we're saying that any SVG should have a stroke of var stroke, and if no stroke is defined, fall back to black. And that's quite handy because here we're saying a naught should have a stroke of the naught color and an X should have a stroke of the cross color, and we defined our colors up here. We have our noughts and crosses, but it'd be neat if we could animate them in as if they were being drawn. Let's start by animating our circle, and to do this we're going to use the stroke-array attribute, and we're going to set this to a value of 200. And then we're going to use a stroke-offset attribute, and we're going to set that also to 200. What stroke-array does is it sets a stroke dash on our element. So here we're saying a stroke dash of 200, but because the offset is 200, we don't see anything. If we set that dash offset to 100, we'll see a half circle. To animate the circle being drawn, we're going to start by defining a draw speed, and let's set that to 0.2 seconds. Then we're going to define an animation for our circle elements. Let's do animation draw var draw speed for the duration, ease in for the timing function, and then let's define those keyframes draw as 2 and then stroke dash offset 0. If we try out our demo, our circle animates in but then disappears, so we can use animation fill mode to fix this. Let's use the value of animation fill mode both because we anticipate that we might use an animation delay. Now our circle reappears. If we try again with a different circle, we can see it animate in. We can also apply the same animation to the paths of our cross, and then we define the same attributes for the paths of our cross. So let's start with stroke-array and give it a value of 100. And then let's define a stroke-offset also of 100. And we apply that to both paths. Now if we test out our demo, our circle animates in and our cross animates in. Our circle will look more natural if it animates around the other way, and to do this we can use transform rotate X and 180 degrees. Now if we animate a circle, it animates around a more natural way. To review, this is a neat little trick for animating SVG paths and other shapes within SVG. Using stroke-array and stroke-offset means that we can use CSS animation to make it seem as if something is being hand-drawn. Sometimes you have to play around with the numbers for the stroke-array and the stroke-offset. You'll usually be able to find a number that works for you. With more complex shapes, you might have to play around with the stroke-array and offset values to get the desired effect, but you should be able to find something that works for you. Let's stagger the animation of these lines so it appears like they're hand-drawn. To do this, we're going to use inline CSS variables to define an animation delay for each line. To work out the delays, we can use DevTools to see which order we want. So we want to animate the first line first, then the third line, then the fourth line, and then the second line. Let's create an array named delays, and this will act as a map of delay multipliers for the lines we render. For example, the first line we render will have a delay of 0, but the third line will have a delay of 1 times whatever we choose the delay step to be. This could be the draw speed. To apply that delay as an inline CSS variable, let's set delay to delays and then delays L. Our delays currently have no effect, so we need to apply an animation delay. We're going to apply an animation delay of var delay with a fallback of 0 and then times var draw speed. We're going to use the draw speed as the stagger for our delays. Now when we refresh the page, our lines are drawn in sequence. However, our crosses still don't have that stagger. To fix this, we can use a scoped delay variable on any path that is env of type 2, which would be the second part of our cross. If we set delay to 1, and now we try this in our demo, we can see that the cross is staggered. Using animation delay with Scoped CSS variables allows us to do quite a few things, and one particular thing is being able to control the stagger of animations, shown in this example. Animating the lines in a stagger gives it a more natural feel that it's actually being drawn. The same with the cross. If we just do both at the same time, it doesn't feel quite right, whereas using a little stagger and some CSS variables, we can achieve a much closer effect that's more natural. Our Tic Tac Toe board is functioning, but there's one issue here. When we render a result, the result actually knocks the board out of alignment, and also we aren't blocking the player from playing on. We could use the result to overlay the grid and stop the user being able to click underneath. If we inspect this, we can see that the game result covers the entire board. And to do this, we're using position absolute with a height and width that are 1.5 times the size of the board. And then we have some styling for the content. But the board is still quite prominent and doesn't feel very disconnected from the result. To create that disconnect, we can use a backdrop filter. And then let's apply a value of blur and let's say 25 pixels. By using backdrop filter, we're able to create a blur for anything in the backdrop, and that shifts the focus away from what's in the backdrop to what's in the foreground. Here, we're sizing up the result element to cover the entire board, and this stops users from being able to click the board once a result has been determined. Using a backdrop filter is a nifty way to shift the focus from the backdrop onto the foreground. One thing we might want to do is animate the result in. When the result is shown, it instantly appears. Let's set an animation on the result and let's call it fly in, and we'll give it a duration of 1 second and it will ease in. Let's define our keyframes for fly in below, and we're going to say our result animates from transform, translate, -50%, 250%, and scale 0. It will also start with an opacity of 0. Let's try that out with our board. And we can see that our result animates in, and we only needed to define the front end of our animation. We could also change from to 0%. We might choose to alter the timing on our animation, and let's say that we only want the result to animate in once the final piece has been drawn. Let's try that again, and now we have the pieces, and when we animate, we get a flicker and then it animates in. If we use the animations inspector in DevTools, we can see what's happening. So here the final piece is being drawn and our result is shown over the top instantly because it has an animation delay. Once the piece is drawn, the animation for fly-in starts and we can see that our element starts flying in from the bottom. To fix that, we can apply an animation fill mode, and in this case we can apply the animation fill mode backwards. What this means is our element will retain the styles applied in the first frames of our keyframes during the delay period. So if we try our demo again and we run the board, that time it didn't flicker. And if we check the animations inspector in DevTools, we can actually see that the green line for fly-in is now solid, whereas previously it was dashed. And if we scrub through the animation, it's not appearing, and then it flies in. To review, we've used animation fill mode here to animate in the result for our Tic Tac Toe board. You can use other values such as forwards, both, and none, but here we're using backwards because our animation has a delay, and animation fill mode allows us to retain the styling from our keyframes when an element isn't animating. Here we're using a from animation, and by that I mean an animation where we're animating from a state to the defined styles. Here we're flying in from off screen and opacity 0 to the defined styles, which are on screen, opacity 1. An animation fill mode of backwards means we retain the styling from the first keyframe, which is off screen, until we're ready to animate. Our result reveals the winner, but it would be nice to give a visual indication too by including the SVG that represents the winning piece. To do this, we could copy the markup for our SVG and paste it into the result elements, but this could incur added maintenance overhead. Instead, let's use Pug Mixins. We can create one mixin for cross and one mixin for naught. Let's start by moving those markup declarations into the mixins. And then let's use our mixins to replace that markup. We use plus and then the name of the mixin and then invoke it like a function. If we check our demo, our SVGs aren't rendering in the correct place. And that's because the X and Y values are no longer being passed through. Because mixins are functions for reusable blocks of code, we can actually create two parameters, X and Y, for each mixin, and then pass them into the mixin when we invoke it. Now if we check our demo, our SVGs are positioned correctly, but we might not want to apply that inline style to every instance of our SVG. In fact, for our result SVG, these styles will have no bearing, so we can remove them, and let's remove the parameters too. Alternatively, we can pass through attributes to instances of our mixin. So here, let's replace passing X and Y and append a style attribute. And the value of that style attribute will be what we had before. To apply that style attribute to our mixins, we can use the attributes variable. So we can do style exclamation equal attributes dot style. And that means that an attribute of style will be applied to a style attribute on the mixin. If we check DevTools, we can see that this is the case and the expected style is being applied to our mixin instance. Now we can add a cross and a naught to our results. And if we check how that looks, it doesn't appear. But that's because our SVG has a class on it which sets display none, position absolute, a height width, a left top, a Z index, and these styles apply to the SVG that are actually within the board and not the ones in the result. So how can we apply a different class? To do this, we can apply class attributes to our mixin instances. The SVG that are absolutely positioned will get a class of game piece, and the SVG that are in the result will get a class of result winner. And then we need to update our mixin code to make use of that. So class exclamation equals attributes dot class. If we check our markup, we can see that our SVG inside the game has a game piece class now, and the SVG inside the result has the class of result winner. And using these classes, we can refactor our styles. We can remove these styles from the O and X rules, and we can apply them under a game piece rule. If we check our demo, this now works as expected, and our SVG appears within the result. To review, Pug Mixins are super useful. We can use them to reuse blocks of markup. They're like mini functions, and we can pass arguments to them and get a block of markup back that we can render. It's really handy as well that we can pass through attributes and then have them applied onto the markup too. That means we can create different variations of our markup, but we keep all the markup in one block, and that makes maintenance a lot easier. What if the SVG had a kind of neon effect? And to do this, we can use the CSS filter property. Let's apply a drop shadow filter with a horizontal offset of 0, a vertical offset of 0, a blur radius of 1 vmin, and then for the color, we're going to use the stroke value. And now our SVG kind of look like they're giving off light. A drop shadow applies a shadow around the shape of an element, as opposed to a box shadow, which would apply a shadow to the box model of an element. We can also chain filters, so let's apply a brightness filter, and let's apply a brightness of 1.2. And that brightens our SVG up, and it almost gives an effect like they're lit up. To review, we're using the CSS filter property to apply visual effects to our elements. In this case, we're using drop shadow and brightness combined to try and make it look like our elements are giving off light. The drop shadow filter leaves this nice blurred shadow effect around the shape of our element, and it kind of makes it look like light bleed. That combined with the brightness filter, just brightening the elements a tiny bit, makes it a bit more realistic and kind of like it's an actual light. It also brings it a little bit close to the neon effect that we're going for here. There are some pretty rad CSS filters you can use, and I'd certainly recommend exploring what's possible. Our Tic Tac Toe board currently uses motion on the page, and this might not be suitable for all users. To detect this, we can use the media query prefers reduced motion. In our demo, all motion is powered by this draw speed variable. So when the user prefers reduced motion, we can set the draw speed to 0 seconds. And now when we check our demo, it still works as before, but using the rendering panel of DevTools, we can emulate prefers reduced motion. Now, if we reload our page, there's no motion to draw any of the elements. To review, we can use the media query prefers reduced motion to detect a user's preference for motion. This is particularly useful for users that could have vestibular disorders and would prefer not to see any motion at all, or very reduced motion. In this example, we're able to use the media query prefers reduced motion and then update our draw speed variable to 0 seconds. And that means that elements don't have any motion, they just render instantly because the animation happens in an instant. We have our functioning Tic Tac Toe board, but it'd be nice to give a visual indication of which piece is going to be placed and where. To do this, let's render the appropriate SVG inside each label. Now all of the SVGs show, which we do not want, so let's apply a class of ghost. And let's define some styles for ghost. By default, every ghost will have an opacity of 0. We only want to show a ghost when we hover over a label, so let's use label hover ghost. And then let's set an opacity of 0.25. And now if we try our demo, we can see that the ghost appears on hover, and then we click to confirm. To make it a little smoother, let's apply a transition of opacity and then use our draw speed variable from above. And now if we check our demo, our ghost fades in with a slight transition. To review, we can use the hover pseudo class to apply styles to a child element. In this case, it's a handy way to do like a show and hide reveal, where an initial opacity is 0, and then we're just raising the opacity on hover. That gives us a way to show these little visual indicators for the grid. We need some confetti. Let's start by creating a mixin named Confetti. And inside this mixin, we're going to use a while loop. Let c equals 0, while c is less than 10. Create a div with the class name Confetti. We're going to give each piece of confetti randomly generated characteristics. So let's start with a skew, and we're going to say math.floor, math.random, and let's do times 25. And then we'll negate 25 on the end. And we can go ahead and create some other characteristics. Now we've got different characteristics defined for each piece of confetti. For example, how far it might travel or how much it's rotated. To apply these, we're going to use the style attribute, and we're going to apply each characteristic through an inline CSS variable. So for example, hue, we will pass in as hue. And we can do this for all of the other characteristics we've defined. The last thing we need to do is increment c for our while loop. Next, let's invoke our mixin so we can see something in the DOM. And if we inspect the DOM, we can see our confetti elements with the randomly generated inline CSS variables. We won't see our confetti yet though, because they don't have any styles, so let's create some. Here we have some basic styling so we can see the confetti elements. We want all of our confetti to spring out from the middle of the grid. So let's start by giving all of the confetti a common start point. Let's go with position absolute, top 50% and left 50%. Then we can transform and use translate -50% and -50%. Next, let's make use of our scoped inline CSS variables, and we're going to start with a rotate. And we're going to use calc var rotate with a fallback value of 0 and then times that by 1 degree. And we can see that our elements are rotating. We no longer have a square, we have the overlap of all of them rotating. Next, let's make use of the travel variable. Let's use translate y and then a value of calc var travel with a fallback of 0 and then times 1 vmin. And now we can see our confetti pieces are all in random positions, shooting out from that center point. And then we can go ahead and make use of the other inline variables. And now we can define an animation for the confetti. Let's go with the name celebrate, and we'll set a duration of 0.5 seconds. And for now, we'll use an infinite iteration count. For our keyframes celebrate, we are going to animate from the starting position. So we can use a 0% keyframe, and we're going to say at 0%, each piece of confetti should be transformed with translate -50%, -50%, and scale 0. But this isn't what we want. Our confetti pieces are just flicking on and off. And that's because this transform structure doesn't match the transform structure in the keyframe. If we were to insert scale 1 here, now we get the desired effect that we were after. And that's because our transform structures follow the same path. To tidy this up a little bit, we can fade out our confetti pieces in the keyframes and use an animation fill mode forwards. And that way, they disappear. All that's left to do is move our confetti into the right place in our demo. And if we give the demo a go, we can see the confetti flies out. But those confetti pieces come in a little quick, so maybe we want to apply a delay to each piece. And we could apply a delay based on the index of our confetti loop. Let's add an inline CSS variable and pass it the value c. Let's apply an animation delay based on our inline variable, and we're going to do var delay +1 and then times 0.1 second. And we're going to change the animation fill mode to both. If we run our demo, and we can see all the little pieces fly off. The neat thing here is we can just change the amount in our confetti loop, and if we try that again, we'll now have 50 different pieces. And we can see them all flying off. To review, using Pug to generate inline CSS variables for elements within a loop and within a mixin is a really neat way to create randomly generated animations. Here we're using it for confetti to make it fly off in different directions at different distances. But you could do other things such as different speeds or different sizes. It's down to whatever you want to pass through in a CSS variable. And that's the power of scoping with CSS variables. Because our keyframes only define CSS transforms at one end of the keyframes, we're animating to the defined styles for our confetti. So we can animate from or to different places based on the CSS variable values. And that makes for some pretty interesting opportunities. Well, that's it. That's one way to create Tic Tac Toe with CSS and SVG. I've tried my best to explain most of the concepts, and I hope you've learned something from this. If you stuck around to the end, leave a bear emoji below so I know who did. And if you're interested in learning more about CSS animation, I did actually write an ebook last year, and you can grab a discount code for that below. But you need to append the word bear to it. And that's it. Stay awesome, people, and take care.